Okay, question 13. The diagram below shows the path of a small rocket which is fired into the air. The height 8 meters of the rocket after t seconds is given by the height after t is 16t take t squared. That makes it a maximum turning point there, just up there. Okay, obviously giving the game away here, but let's go to question A. After how many seconds will the rocket first be at a height of 60 meters? Okay, so we want to know, we want to set this equal to 60 and see what values of t correspond to that. Okay, now what I do here is I don't like negative t squared, so I'm going to move everything over to the right hand side. So negative t squared becomes t squared, there it is there. 16t becomes negative 16t, and the plus 60 shuffles down a bit. Okay, you have to be quite good at factorising here. Although if you use the quadratic formula, it would work, be a bit slower, but it would work. Okay, for A is 1, B is minus 16, T is C 60. Anyway, factorising does it a lot faster. T times T, T squared, T times minus 10, minus 10T, take away another 6T, minus 16T, and minus 6 times minus 10 gives plus 60, of course. So these are the two values of T that correspond to a height of 60 meters. The question is, after how many seconds will the rocket first be at a height of 60? It will be after 6 seconds, and that's on the way up, and it will be at 60 again after 10 seconds on the way down. Will the rocket, this is part B, will the rocket ever reach a height of 70 meters? Okay, well, the way I saw this was, what is the maximum height that the rocket gets to? Okay, will it get to 70, above 70, or whatever? So we need to find the roots of the equation. Get back to what I alluded to earlier on. We need to find where the graph cuts the t-axis. 0, and I've given it away here at 16. Okay, we want to set the height equal to 0. Remember, 16t t squared was the height. We want the height to be 0. Okay, now this is quite easy. We can take out t's to factorise. So t equals 0 and t equals 16. Okay, 0 and 16 take 16 would give 0 as well. Okay, so the height is 0 at 0 and 16. Now, because this graph is symmetrical, the maximum height it gets to corresponds to 8, halfway between 0 and 16. Okay, so the maximum height is when t is 8. What is the maximum height? Well, we can just use the formula. 8 of t is 16t take t squared. Put in 8 and let's see what the maximum height is. 16 times 8, 128. Take away 8 squared, 64. That gives you a height of 64. So don't forget to summarise your answer. The rocket will not reach 70 as the highest it goes is 64 meters. And there's a few wee chimney sums I did earlier on to help me.